Okay, so filling in the blanks. It says a rational expression is in simplest form if its numerator and denominator have no common factors other than 1. So I want you to squeeze in, there's a little bit of space here. I want you to put a note. You may cancel common factors, but not terms. This is very, very, very important because I have students every year in Algebra 2 try to cancel terms when you can't do that. Factors, and so I think we've got a little bit of space here to the right. Okay, terms are separated by addition and subtraction signs. Okay, terms are separated by addition and subtraction signs. Factors are separated by multiplication. So I cannot cancel the 2 and the 6 under the terms because it's not a factor. Okay, so that's very, very important you understand. But I could cancel the 2 and the 4 here because it's 2 times and 4 times. But here I can't cancel the 2 and the 6. It doesn't work that way. All right, so if you want to simplify rational expressions, there's 2 steps. Factor the numerator and denominator if possible. Now sometimes, like in example 3, it's already factored, so you're done with that step. And step 2 is then cancel the common factors. So in example 1, let me give you a head start on me, and I want you to think it through. Factor your numerator, factor your denominator. The denominator does factor. This was called a difference of 2 perfect squares. So you're supposed to remember all the factoring from chapter 4 and chapter 5. All right, in example 1, this factors into x minus 5 times x plus 3. Check your work when you factor. In the denominator, this is a difference of 2 perfect squares. So that factors into x plus 3, x minus 3. Now I have it factored. Factored is multiplication. So I can cancel the x plus 3's, and you get x minus 5 over x minus 3. You cannot cancel the x's because they're terms. All right? Now, I want you guys to try example 2 and 3.
That's it.
That's it. That's your final answer. So all we're doing is simplifying the fraction. So you factor the numerator, factor the denominator, cancel the common factors. So it's like, reducing 4 over 8, but much more complicated, okay? Okay, example 2. This numerator factors into x minus 4 times x minus 4. That's called a perfect square trinomial. That'll be helpful when they get more complicated. The bottom factors into x plus 6, x minus 4. So that reduces to x minus 4 over x plus 6. So you guys, what we're doing here is we're just reducing the fraction. Rational expressions, that's a fancy word for a fraction with variables in it, okay? All right, example 3, don't multiply it out and then refactor it. It's already factored for you, so the x plus 1's cancel, and you end up with 2 over x plus 3. All right, any questions on the first one? Okay, in example 4, when you go to factor, for whatever reason, we seem to we can say what step 1 is, but we forget step 1 at the same time. So step 1 is look for the GCF. In the numerator, what's the GCF? 20. So you pull out a 20 and you get 2x plus 1. In the denominator, the GCF is 10 and you get x plus 3. Now I can reduce 20 over 10, but it doesn't cancel all the way. 10 goes into 10 once, 10 goes into 20 twice. So this is 2 times the quantity, 2x plus 1. And down in the bottom, we're not going to put 1 times x plus 3, because 1 times x plus 3 is just x plus 3. All right, example 5. I've got 4 over x times the quantity x plus 2. This one is already simplified. You cannot cancel the 4 and the 2 just because you think, hey, I'm supposed to do something. You can't make stuff up. 2 is not a factor, so it doesn't cancel.
There's going to be something like that on homework.
There could be. So, if there's nothing else to do, then you need to say that. All right, example 6. X plus 4 is already done, but in the bottom, x squared minus 16 is a difference of 2 perfect squares. So that's x plus 4 times x minus 4. And the reason why I put this one on here is I have students who make a common mistake. When I cancel, I have students say that the answer is x minus 4. Why would x minus 4 be the wrong answer, Michael? Yeah, this is still a fraction, and I actually have a 1 in the top. And the x minus 4 can't magically go up to the top. So just be careful with that. All right, example 7. I want to go over this because this is going to end up creeping in once in a while. I'm not going to do it a lot, but it will come in once in a while. So in example 7, I have x minus 5 over 5 minus x. So this does not cancel, as a straight 1. Okay, it does not cancel to 1, but it actually is going to cancel. And let me show you how. In the numerator, what I'm going to do is I'm going to use the commutative property. And the commutative property back in Algebra 1 said if I have a plus b, I can change it to b plus a. I can switch the order. 3 plus 5 is the same as 5 plus 3. So x minus 5 is the same as negative 5 plus x. Okay, that's true. Now watch what I can do. I can factor out a negative from both terms in the numerator. This is one I want you to just really kind of let it sink in. What I did, and so each line is equivalent to the line above it. So if I factor out the negative sign, do you see how I got 5 minus x? Because negative times 5 is your negative 5, but negative times negative x is in fact a plus x. You see that? I really did factor that out. Now I have the numerator factored. It's a negative, it assumes really negative 1 times 5 minus x. That cancels to negative 1. So here's the big idea. If you have in general a minus b over b minus a, this will reduce to a negative 1. Okay? A minus b over b minus a is going to reduce to a negative 1. All right, so let's look at example 8 together. I'm going to factor the numerator and the denominator. The numerator is no big deal. That'll be x plus 3 times x minus 2. In the bottom, do not switch the order around. I'm going to leave it the way that it is. 5 times 2 is 10. I'm going to need an x and an x. And I'm going to think about FOIL. Okay, I'm going to think about the outer and the inner. And I want the outer and the inner to add up to a negative 3x. So with a 5x and a 2x, I need the 5x to be a negative. So I'm going to put the negative actually over here, because see, that'll give me minus 5x plus your 2x. And I needed one of each sign in front of the x to make it a minus x squared. Now watch this. This connects. There's a method to my madness here. Look at example 7 where we said a minus b over b minus a is negative 1. So x minus 2 over 2 minus x reduces to negative 1. So this is a negative times the quantity x plus 3 over 5 plus x. Okay, so be very, very careful with that. All right, you guys try example 9 on your own. In the bottom, there's no GCF. And either you're going to use your slide method, if you remember that, or I'd like to encourage you to try trial and error. If you're going on to pre-calculus, regular CCP, pre-calc students should be able to trial and error. So the bottom, let me give you a moment to sort of struggle with it. All right, in the numerator, don't forget about step 1. There is a GCF. So I pull out a 2x and get x plus 5. All right, let me go over the trial and error technique, because I really, really would like you to be able to see if you can handle this instead of that slide method. So here's the deal with trial and error. With 3x squared, this one's a nice one, because the only way to get 3x squared is 3x times x. Then what we mean by trial and error is to get a 5, it's either 1 times 5 or 5 times 1. And all you do is you try each one and see with FOIL which one works. So the thing is, if you think about this, here's 15x plus 1x gives me 16x. If I put the 5 in the 1, that's 3x plus 5x is 8x. It doesn't work. You erase and try again. But I'll give you a giant hint. If there's an x plus 5 up here, there's like a 99% chance there's an x plus 5 down here. Okay, so be smart about your choices. So now the x plus 5 cancels, and I have 2x over 3x plus 1. So the nice thing about simplifying, and then we're going to do multiplying and dividing, is there's usually hints in one location. So like the numerator was easy, pull out the GCF. So there's like going to be a 99% chance there's an x plus 5 down in the bottom, so you try that with your combination.
Does that mean you're bringing long division back?
No, not yet. Alrighty, so now you should see multiplying. I skipped something I used to do. So multiplying. If you want to multiply rational expressions, what you do is step 1, factor the numerator and denominator, if possible, and then cancel common factors. So example 11 and 12 are a little bit different because there isn't any factoring that we can do. But what we can do is we can multiply first. So 8 times 7 is 56. X cubed times x to the 4th is x to the 7. Y times y cubed is y to the 4th. So you can begin to appreciate why we reviewed exponent properties in chapter 6. In the bottom, 2 times 4 is 8. I only have an x, and then y squared times y is y cubed. Now we're going to reduce it if possible. That's, canceling common factors. Well, 56 over 8 is 7. What's x to the 7 over x to the 1st? X to the 6th. And y to the 4th over y cubed? Y. All right, you guys try example 12. Multiply it together first, then reduce. Okay, so you get 135 x to the 7 y cubed over 45 x to the 5th y to the 5th. So this is 3x squared y to the negative 2. And remember, you can't leave a negative exponent, so the y to the negative 2 is going to drop down. All right, questions on those two? Okay, we're going to get to example 14, then pause, and I want you to have a few minutes to work on the homework. In 13, here's where it gets a little bit more interesting, and this is where the steps really make sense. What you want to do is you want to factor first. So in my first numerator, there's a GCF. I'll pull out a 3x, and I get 1 minus x. In the denominator, this is x plus 5 times x minus 1. Over here, I'm going to get x plus 5 times x minus 4. So when it's polynomials, not just single terms, you're going to factor each numerator and denominator and see what kind of canceling you can do. Well, I can definitely cancel the 3x and 3x. I can cancel the x plus 5. What can I do with 1 minus x over x minus 1?
Negative 1.
Nice, that's a negative 1. So then let's look what's left, and I've got a negative 1 times x minus 4. That's negative x plus 4. There's nothing down in the bottom besides a 1. So you're not going to leave over 1. That's not as simplified. All right, you guys try example 14 on your own. Tonight's homework, you're going to do the front of the worksheet. Tomorrow, I'm going to finish the notes, finishing one more multiplication problem in example 15, and then we're going to learn about division. It's actually not too bad. And if you noticed the calendar, what we're going to do this week is we're spending 2 days on 8.4, then we're going to have a quiz Wednesday. Thursday, Friday, you have your post-test. I've got your scores so you can see what you need to get on the post-test in order to get exempt from my final. I'll pull those up and kind of tell people. Yes.
Sure. If it's 5x over x, the x's cancel.
Yes.
Okay.
And the reason why is 5x is 5 times x, so that is multiplication there. Okay, don't forget about step 1 in factoring. Look for the GCF. In my first fraction, I have a GCF in both spots. And then Joey asked a really good question. If you have 5x over x, the x's do cancel. My x minus 1 cancels, my x plus 4 cancels, and then 4 minus x over x minus 4 reduces to -1, and I have a -5.